keep recording here. All right. Don't know exactly where I dropped out, but x e to the x squared. So I know that the integral of e to the u is just e to the u. So that's pretty nice. If I somehow make that look like that, that would be good. I know I have this x, it's annoying, but at least if I could turn this into u, so I'm going to try that. And sometimes you try things and they just don't work. So try something else. So at least this would become e to the u. What about the rest? Well, I've got an x and I've got a dx, and I hope that that is fixed when I find du. And it will be. So 2x dx is the du, because again, you take the derivative and then tack on dx. And here's one where, again, maybe we'll go back and try this. Dx itself is 1 over 2x du. And I still don't ever feel comfortable on this because you're mixing them, but you realize that you'll have an x from the original problem. And now dx, when I replace that in there, will be 1 over 2x, and the x is okay. So I would just have 1/2 e to the u. And now that one I can do 1/2 e to the u. It's the same thing, plus c, and then replace. So 1/2 x, 1/2 e to the x squared. Now, as a little bit of foreshadowing, I will point out that if you had the problem e to the x, e to the x, and that was not squared, is different. And we're going to have to come up with a different way to handle that. So if this is not a 2, the problem becomes much different, if not impossible to solve. So the fact that this is a 2 is really important, that the derivative of the x squared is the x, and it balances everything. These are very sensitive to the small changes.
So what was the answer exactly?
It was 1/2 e to the x squared.
Okay.
Yeah. Quick, very easy verify on this one. If we were to take e to the 1/2 e to the x squared and took the derivative, it would be 1/2 e to the x squared. The rows repeat, but then the chain rule would say you have to multiply by the derivative of the power. That's chain. And the 2's will cancel, and I'll get x times e to the x squared, which is back to what I started with. So that's one of the shorter verifications. So I put that in. Yeah, so 2 more here. So this is second to last one. This one is when it starts to get a little weird. So this one, you can sit there and try and play, and you'll notice that you first have to write this as the product of 2 things. So whenever you have a divisor here, which has the product, you can write it as 1 over that first one and 1 over the second one together. Now the pieces start to come together. You've got log, you've got 1 over x, you start to see patterns in here. So again, if you're not sure what to do, try something. And so I'm going to try the u equals ln of x, because that's ugly to start with. So if I was to replace just that little piece right there, at least I would have 1 over u. Now, what about the rest? Well, I've got 1 over x, and I've got dx, but hopefully when I find my du, all will be well. So if I take the derivative of natural log, so I take the prime, that is 1 over x. That's good. And then I always tack on the dx. So those go together, and then you have your u prime there. So, phew, that right there is exactly what's left. The 1 over x and the dx. I could multiply it over here if I wanted to. And I just get straight up equals 1 over u du. But it's lucky that this guy balanced out exactly what this one was here. I just fit this one over here. This is much easier. Yay. So if I take the integral of 1 over u, I get the natural log of u plus c. I've already wrote that on the previous slide. Natural log of u plus c, and then I replace. So, and you're like, this is weird because it's the natural log, but if I replace u, that's also a natural log. And the answer is yeah, that's right. It's like the natural log of the natural log. So it's even worse. You can verify that this is correct. You take the derivative, it's 1 over what's inside, which is 1 over ln x, times the derivative of the inside, which is 1 over x. And so I get exactly back to where I started. All right. One more, then we'll do questions that you have. And this one is trickier. Integral of tangent. So the first thing you might notice is, well, there's only one function in there. So do u equals tangent? Question mark. So we try that. If we did, then my du, you can remember the derivative of tangent. Go back into your brain or look in the tables. That ends up being secant squared. And that's sort of nowhere to be found. There's no balancing in here. I wouldn't even know how to stick that in. If I did, I'd have a bunch of x's and u's put together. And so this is sometimes better than getting the right answer, getting the wrong answer or the wrong method and going, that's not right. That's not the right. It's not the right substitution we want to use. So if that's not the right substitution, then what else could you do? So here's where you have to do this little trick. And remember, tangent is sine over cosine. Okay. Now this is good. This does give me a chance to do a substitution. And I have two choices. I could either try u equals sine, or I could try u equals cosine. And I'm going to let you try this one. We're going to work the second one. But try this one and see that this ends up leading to a problem. You do the derivative, you've got cosine. The problem is the cosine's in the bottom and the sine's in the top. So when you try and do all this stuff, the du ends up being in the denominator, and that's not legit. You need to have it right here. Du and dx and all these d's have to be right on the end. So that one doesn't end up working. But I think you need to work it out and see why. This one, if I did u equals cosine, the derivative is minus sine and then dx. So things look pretty good. I've got cosine there, and that looks like u. And then the rest of this stuff together, sine x and dx together. Well, there's a minus here, but you can always just, you can always multiply both sides by minus. At least that would mean that the rest, sine x and dx, becomes negative du. So my integral becomes 1 over u with a minus. And put the minus here, minus 1, put the minus on the outside, it's just a constant multiple of negative 1. So shoot, that one is a lot nicer. It ends up being negative the natural log of u plus c. Those are popping up in here. U plus c. And now I replace, because I want to get back to where I started from. So this is the negative natural log of u, which is cosine. Let's see. So we sort of come a long way from just the integral of sine of 2x all the way up to one that look like this in a very short amount of time. But there's no secret. You just try a bunch of substitutions, see if you can get the algebra to work out. make the integral easier so you can actually complete it and then replace back. We'll do a few more of that on Tuesday. But I did want to make sure that we had time for questions. So I don't know, maybe just a quick 2-minute break, and then we'll start that. So, 2 minutes here.